Hey, so today we're talking about proportional reasoning. And last time we talked a little bit about proportions. We said that a proportion is just a statement that says that two ratios are equal. I've got two proportions right here. So really, these proportions are just describing some equivalent fractions. Example 1 says that 7 over 3 is the same thing as x over 84. Example 2 says that 5 over 60 is the same thing as 3 over x. So that's all I've got here, just two pairs of equivalent fractions. The only thing is that I am missing a numerator in example 1, and I'm missing a denominator in example 2. But we can use what we know about equivalent fractions to figure out what those should be. Let me tell you what I mean. So looking at example 1, I want to look at my numbers. And specifically, I want to look up and down or horizontally. So I want to look either vertically or horizontally to see if I can spot any multiplicative relationships within these numbers that I've been given. Take a minute and look at these ones, see what you think. So after looking, I noticed 3 doesn't go into 7, so that relationship is at least not evenly, so that relationship might be a harder one to work with. But 3 does go into 84. And so if I can figure out how many times 3 goes into 84, I can multiply by that number to get 84 in the denominator. And then I should be able to multiply by that very same number to get x in the numerator. Let's see how many times 3 goes into 84. Let's just do the division really quick and see what we get. So 3 goes into 84 28 times. I could write that 3 times 28 is 84. And that means if I multiply by my numerator by 28, this will not change the value of my ratio because I'm doing the exact same thing to the numerator and the denominator. I'm multiplying them both by 28. So I still will have equivalent fractions. And multiplying 7 times 28 will give me x. It'll tell me what my numerator should be that goes with a denominator of 84. So let's do that. We need to do 28 times 7. And that comes out to 196. So I know that my answer here is that x is equal to 196. In other words, 7 over 3 is the same thing as 196 over 84. And you know what? If you weren't sure, you could type those in a calculator, and it would give you the same value for both 7 over 3 and 196 over 84, because those are equivalent fractions, and it's a true proportional relationship. Let's look at example 2. So remember, I want to look both vertically and horizontally to see if I can see multiplicative relationships between the numbers I've been given. Take a look for a minute. So 3 doesn't go into 5 evenly, but 5 goes into 60 12 times. So this time I'm looking within my ratios. I'm looking for a relationship between my numerator and my denominator. And I know that 5 times 12 is 60. Well, since these ratios are equal, since I'm looking at equivalent fractions, that'll be true for my other ratio too. That means that 3 times 12 will give me x. And 3 times 12 is 36. So I know that x is equal to 36. 5 over 60 is the same thing as 3 over 36. Okay, now it's your turn. Pause the video and give it a try with these ones. Okay, if you're ready to see the solutions, then hit play. For the first practice problem here, we notice that 4 times 15 is 60. Then we know that 5 times 15 will give us x, and 5 times 15 is 75. So x is equal to 75. We use relationships between our ratios to find x. And on the next one, I noticed that both 2 and 38 were even numbers. That means that that there's a number that would go into both of them. And that number is 2. So 38 divided by 2 was 19. That told me that 2 times 19 is 38, and 7 times 19 must be x. This relationship is going to be true between the numerator and denominator of both pairs of my fractions here. So multiplying 7 by 19 gave me 133. X must be 133. In other words, 2 over 38 is the same as 7 over 133. And we got that by multiplying our numerators by 19 to get our denominators. So at this point, you get to try some practice problems, and then in a little bit, we'll talk about some other things you can do with proportional reasoning.